Okay, so to continue, we say that the alternating harmonic series converges conditionally because the absolute value of the series does not converge. Otherwise, in other words, it does not converge absolutely, but the series converges conditionally. So we're going to do number 23 as an example, and you will be doing 24 through 26 on your own as practice. Okay, here's number 23. Here's a series that is alternating. 1 plus n over n squared is your u sub n, and it's alternating in sign. Here are the first three terms, and this would be u sub 1, this is u sub 2, and so on. So since the terms are positive but alternating in sign, we are going to use the alternating series test. So the conditions are, first you want to check either the terms without the sign are positive, and 1 plus n over n squared is positive. Second condition is that u sub n is greater than or equal to u sub n plus 1, or that the terms are not increasing. It appears to be so, but the way to know for sure is to do the third condition, which is to check to see if the limit as n goes to infinity of each term u sub n is equal to 0. In this case, this term, the limit mimics limit of 1 over n, and it goes to 0. So it satisfies all three conditions of the alternating series test. So we know that the series converges conditionally. So the second part to complete this test is to see if the series converges absolutely. And to do that, we're going to test the absolute value of the series, 1 plus n over n squared, and we're going to use the limit comparison test to do so. So the limit comparison test says this series, the limit of this series is compared to the limit of another series. So we're going to compare the limit of this series, which is 1 over n, and let's call that a sub n, and I'm going to compare that to b sub n, which is the harmonic series itself. So if I compare limit of a sub n over b sub n, I get 1, which is a constant, which means they both diverge or converge together. And since the harmonic series diverges, that means the other series, the original series an, also diverges. So that gives us that the original series converges conditionally, but does not converge absolutely. So the final answer is the series converges conditionally by the alternating series test. Now go ahead and do number 24 through 26. Walk through all the steps and ignore the truncation error part of the problem. And I will post my workup on Google Classroom when you're done.